This summer I went on a geology excursion, which was quite exhausting, but also very interesting. We visited a long list of geologically interesting sites, and I'd like to share a few of the things I've learned with you guys. I'll start with an interesting little factoid technicality. And I know this sounds kind of absurd, but technically, since the term rock just means a naturally occurring solid aggregate of one or more minerals or mineraloids, water ice is actually a rock. Glaciers are indeed considered to be a kind of rock formation in geology. Following that reasoning, we call molten rock magma when it's underground, and lava when it's above ground. So groundwater is magma, water above ground is lava, and a geyser is a volcano. Technically. Now, let me take you through a few of the interesting locations we visited on this trip. Volcanoes are obviously obligatory to mention here. We visited Amboy Crater, a cinder cone formed during an eruption around 10,000 years ago. We also went through Long Valley Caldera, a volcanic depression that formed after a massive eruption about 760,000 years ago that blasted material 100,000 feet up faster than the speed of sound. The obsidian domes at another site were formed quite differently. Magma reached the water table, broke up through already cooled rock, and solidified at the surface, forming a blocky dome shape of almost pure obsidian. There was little to no gas in this magma, otherwise it would have caused an explosion. The youngest of these domes formed about 550 years ago. On a geological timescale, that's basically yesterday. Besides the cool volcanoes, we also went through Death Valley, which was hot and dry and pain, and occasionally the teacher had to actually trick us into coming out of the air-conditioned van to look at something. Temperatures were around 50 degrees Celsius, in the 120s in Fahrenheit. The highest temperature recorded was on July 10th, 1913, at 134 degrees Fahrenheit or 57 degrees Celsius. At the bottom of Death Valley is Badwater Basin, at 282 feet or 85.5 meters below sea level. It's the lowest point in the Western Hemisphere. Only the Dead Sea is lower. Water is always present here, but because of the salt buildup, it's always completely saturated with salt. In fact, a thick layer of salt is visible. Only halophilic bacteria could live here. A little higher up, we find Devil's Golf Course. Water is pulled up to the surface by capillary action, leaving behind the dissolved salt as the water evaporates. This process creates a rough terrain of salt pillars, so rough that only the devil would play golf here. This area is above the water table, so water does not flow down to rest here. This stops the salty terrain from being redissolved and evening out. Next stop is Ventifact Hill. Vent is the French term for wind, which came from the Latin word ventus. This hill is above sea level, and due to the dry conditions, hardly any rain ever falls here. This means that the main form of weathering here is mechanical, mainly sandblasting by the wind. This form of weathering is usually not visible. It doesn't have the chance to build up because the stronger effect of water weathering tends to mask the minute scratches and pits created by sandblasting. This place is unique to observe the effects of mechanical weathering due to how inaccessible it is to water. On the surface of Mars, though, this type of weathering would be very common. Next up is Mono Lake. Mono Lake is a closed hydrological basin, which means that water can flow in but not out. The water can only leave through evaporation, leaving behind the trace amounts of minerals that were brought in from freshwater streams and underwater springs. Water evaporates from the lake at a rate of about 4 vertical feet per year, leading to an environment that is 2 to 3 times saltier than the ocean. An estimated 280 million tons of solids are dissolved in the lake. Solutes found in the lake are mainly sodium salts of chlorides, carbonates, and sulfates, making the water not just salty, but also highly alkaline. The pH is about 10, and the water feels slippery and soapy. This alkalinity is strong enough to deteriorate clothing and footwear after repeated exposure. A feature that clearly stands out in this lake is the tufa towers. The tufa towers are strange shapes of common limestone, calcium carbonate. They form where calcium from the springs mixes with the lake water rich in carbonates. Tufa forms exclusively underwater, and some of the towers are up to 30 feet tall. They were exposed after a water level drop due to freshwater streams being diverted to supply Los Angeles starting in 1941. The lake reached its lowest level in 1995 when it had dropped 40 vertical feet. Exposed organic debris from the lake led to air pollution laws being broken, and measures were taken to slowly raise the water level up to 25 to 15 feet under its original pre-1941 level. While the water is slowly rising, that goal has yet to be reached. Mono Lake is home to a unique and fragile ecosystem consisting largely of alkali flies, brine shrimp, and birds. They were also affected by the water level drop, which doubled the salinity and turned islands that were being used as bird nesting areas into peninsulas accessible to predators. Reaching a higher elevation and more tolerable temperatures, we visited Inyo craters. This is a set of 3 craters that are about 650 years old. They formed within hours of each other. This area was inhabited at the time, so you can try to imagine what that might have been like. The craters are the result of a steam explosion rather than a standard eruption. Magma reached the water table, causing rapid evaporation and expansion, but the magma itself never reached the surface. At a still higher elevation, we reach Yosemite National Park. The highest point here is Mount Lyell, at 13,114 feet, or 3,997 meters. The landscape of Yosemite was formed by glaciers. A good example of the result of glaciation is the Hanging Valley at Bridalveil Falls. This structure was formed by a glacier eroding into a valley that was created by another glacier, creating a valley that hangs above another valley. Modern snowmelt falls down from here during most of the year. Hanging valleys are common in glaciated areas, leading to the formation of numerous waterfalls. Another sign of glaciation you can see here are scratches in rock faces that formed because of rock debris that was dragged along by glaciers and scraped against the surface. The most common material here is granite, which formed underground and was exposed 25 million years ago when the area was stripped of sediment by uplift and glacial erosion. The valleys of Yosemite are covered in trees, and some of them are proper giants. The next stop, Devil's Postpile, was, in my opinion, one of the most interesting spots we visited. It's a great example of what's called columnar basalt. This shape forms when magma comes up through the existing rock, but can't make it to the surface and instead ends up squeezing in between the existing layers. Some of the columns are over 60 feet tall. The structure was formed less than 100,000 years ago. Columns can be 4, 5, 6, or 7-sided, though 6-sided is the most common form. That's due to the fact that tension cracks tend to form at 120-degree angles, leading to hexagonal shapes. The columns form through cooling and cracking cycles, in which cooling happens from both the top and the bottom, as well as from the sides where cracks fill with water. The material is basalt, a dark rock with some white crystals. It's porphyritic, which means that the crystals are of different sizes. The smallest crystals can tell us where it was formed, in this case, slightly underground. Because it was formed underground at high pressure, there are no bubbles and the material is very dense. At about 3.2 grams per centimeter cubed, it's significantly denser than granite. The structure was exposed through glacial erosion, which you can tell from the glacial striations, the scratches, that you can see on the surface. I hope you enjoyed this very brief peek into a few interesting geological phenomena. If you did like this video, please give it a like, share it with your friends, and subscribe to my channel for more. If you want to support this channel, you can do that on Patreon. A huge thank you to my current patron, Sandy Smith. See you in the next video!